Okay, shall I now write the heading? Motion under gravity. Motion under gravity. Yes, tell me. Okay. I yesterday told you that we will start graph today, but I will start the graph at the ending of chapter. Okay. And once we complete motion under gravity, then relative velocity, we will start the graphs. Okay. Now, write the heading motion under gravity. Written? Okay. Now, for example, consider here is the ground. Okay. If you throw an object in the upward direction, will you require some initial velocity? Do this object will go without initial velocity in the upward direction? No, no. It requires, if I, for example, I am holding a chalk piece in my hand. Will this chalk piece go automatically in the upward direction, or do I need to push this with some initial velocity? I have to throw this object in the upward direction with initial velocity. Without initial velocity, this object does not move in the upward direction. Yes or no? Okay. Consider I am throwing this with initial velocity u. Initial velocity is what? U. Okay. Once I throw the object in the upward direction, will that object continuously go in the upward direction, or will it come back? Yes, it will come back. Why it come back? Yes, because of gravity. So we say that gravity is acting in the downward direction, and we write the acceleration, that is g. And this g is called as acceleration due to gravity. Okay, now, and this g will be having a value 9.8 meter per square second, or sometime we will consider this as 10 meter per square second. And in terms of feet, this can be written as 32.2 feet per square second. Okay. Now, if the question says that the g value is 9.8, you have to use 9.8 only. If the question doesn't say anything about g, even though you have to use 9.8. If the question says take g is equals to 10, you have to take g is equals to 10 only. Got my point? But in our class, for easy simplification, we will consider the value of g is 10. Okay, now, g is acting in the downward direction. We already learned that if a body is moving in this direction, let's say 10 meter per second, its initial velocity u. Okay. If I say this body is having an acceleration that is equals to 10 meter per square second, that means I can say that body is increasing its velocity by 10 meter per second in each second. After 1 second, what will be the velocity? Yes, 20. After 1 second, the velocity becomes 20 meter per second. After 1 more second, the velocity becomes 30 meter per second, so on. Are yes or no? Okay. Now, whenever we found that whenever velocity is increasing, increasing, then acceleration is positive. Acceleration is what? Positive. That means, can I say that velocity's direction and acceleration direction both are in the same, both is same? If, for example, velocity at this point is 30 meter per second, after 1 second velocity is 20 meter per second, after 1 more second velocity is 10 meter per second, can I say that velocity is decreasing? Even though body is moving in this direction, this is the direction of what? Velocity. What will be the direction of acceleration? In the opposite direction. So again is opposite to the direction of motion. Same thing which we learned in horizontal, now we will learn in vertical. That's it. Only we are changing the name of this acceleration as acceleration due to gravity. Got my point? Okay, now come back here. An object is being thrown with initial velocity u meter per second. Will this object continue in the upward direction, or at maximum point it reach here, then it will come back. It will be going like this. Then it will be falling into the same point. Yes or no? Yes. What I want to say is, why this object is turning back first thing? Why this object is returning back to the original path? Because in the initial over here, then after this, it is coming in the downward direction. Direction is changing but following the same path. First in the upward direction, then again on the same path, it is coming back in the opposite direction. Now, at this point, can I say that we also know that whenever velocity at particular point becomes 0, the body will retrace its own path. Body will retrace its own path. We have seen that. Same thing is happening here. At this point, velocity is becoming what? 0. If velocity doesn't become 0, obviously the object will be going further ahead in the upward direction. Yes or no? Unless and until velocity becomes 0 at a point, object won't come back from that point, particular point. Maybe the velocity is becoming 0 here. Maybe the velocity is becoming 0 here. Okay. So wherever the velocity becomes 0, object will be coming back. Got my point? And object is coming back due to what? Acceleration due to gravity. Now, for example, consider this velocity is 100 meter per second. This velocity is how much? 100 meter per second. After 1 second, velocity decreasing or increasing? Decreasing. Let the value is 90. After 1 more second, 80. After 1 more second, 70. So on, the velocity at this point becomes what? 0. Then, if velocity is 0, if I consider acceleration due to gravity is 10 meter per square second, that means can I say velocity is increasing or decreasing by 10 meter per second? G is acting in the downward direction. Yes or no? Okay. Now, one more time. At this point, initial velocity is 100. G is acting in the downward direction. If G is acting in the downward direction, it should be reducing the velocity or increasing the velocity by 10 meter per second. Reducing the velocity. If reducing the velocity means after 1 second, what is the velocity here? 90. After 1 more second, 80. After 1 more second, 70. So can I say that after t is equals to 10 second, velocity is becoming 0? Velocity is becoming what? 0. Similarly, I am saying that while returning back to the original path in the opposite direction, now at this point velocity becomes 0. Why? Because it reached to the maximum height. After 1 more second, G is acting in the downward direction. Velocity is also acting in the downward direction. Can I say velocity is increasing by 10 meter per second? So what is the velocity after 1 more second? 10. After 1 more second, it becomes 20. After 1 more second, it becomes 30. So on, it will hit the ground by the same velocity, that is 100 meter per second. Got my point? What I am trying to say. So acceleration due to gravity is telling you that how much velocity is increasing or decreasing. When it is increasing, when body is falling back to the ground. And when it is decreasing, when we project the object in the upward direction. Got my point? Okay. Then next. Okay, now listen to me. Consider object is thrown in the upward direction with u initial velocity. Object is reaching to the maximum point, then it is hitting back the ground. Thrown from which point? Ground. Reach to which point? Ground. What is the net displacement? 0. So when I am talking about ground to ground, whenever I am talking about ground to ground, can I say that displacement is 0? Can I say that displacement is 0? Okay. At this point, velocity is what? 0. At this point, initial velocity is what? U. G is acting in which direction? Downward direction. When object is moving in the upward direction, velocity is increasing or decreasing? Yes. Velocity is decreasing in the upward direction. When the object is moving in the upward direction, velocity decreases. When the object is coming back to the ground, velocity is increasing or decreasing? Velocity is increasing. Got my point till here? Okay. The next thing, let us try to derive some equations for this one. Now, generally we will be having three equations. Now, first equation is S is equals to ut plus of half at square. Second equation is what? V is equals to u plus of at. And third equation is v square minus of u square is equals to 2as. Don't write anything. Just listen to me. Even if you miss the writing, the classes are on recording now. You can write afterward. First listen to me. Now, wherever you find A, convert that A in terms of G. A in terms of what? G. Now, the second thing, whatever the direction above the ground should be taken as positive. And when it is coming in the downward direction, that means upward take as positive. Upward, all the direction should be taken as positive, and negative means downward. Okay. Whenever it is coming in the downward direction, all the things are negative, and whenever it is going in the upward direction, all are positive. Okay. Now, for example, let us try to substitute this in first equation. Considering first equation, what is the displacement when the object is thrown from the ground and when it is reaching back to the ground? 0. So, S is equals to ut plus of half at square. I am saying that ground to ground displacement is what? 0. What velocity we have thrown the object? U. So, 0 is equals to ut minus of, can I write, half gt square. Okay. Even the object is moving in the upward direction. Where is G acting, beta? Downward only, na? When either object is going in the upward direction, either the object is coming in the downward direction. Where is G acting? Downward only, na? Okay, first thing. Second thing, when object is going in the upward direction, velocity is increasing or decreasing? Decreasing. If velocity is decreasing, then acceleration is opposite to the direction of motion. Then we write negative. Second reason. Okay. Now, over here, can I write ut is equals to half gt square? Can I write like this? Can I cancel this t and t? Or can I say that t is nothing but 2u upon g? 2u upon g. Similarly, if I want to use the second equation, if I am using the second equation, what is our second equation? V is equals to u plus of at. What is the final velocity at h max? And this particular height is called as what? H max now. At h max, what is the velocity? 0. If I say 0 is the velocity at h max, v is what? 0. So 0 is equals to u is u minus of gt. Can I write like this? Or can I also write like this? T is nothing but u upon g. Can I? Achha. Whenever initial velocity and g is there, if we are calculating the time, how the object is going? Object is going in the upward direction and we are calculating the time period in this direction. This is your t. Okay. Why? U is there. So initial velocity and we are calculating time, then it is called as time of ascent. Okay, and this is called as time of flight. This is called as what? Time of flight. Here we have calculated the time period for going the object from ground to h max, then from h max to the ground. This is the total time period. Then it is called as time of flight, and when it is going from ground to h max, then it is called as time of ascent. Similarly, if the object is coming back to the ground, what is the velocity here? V is equals to 0 and u is equals to u. While coming back, can I say that this initial velocity is 0? This is in the upward direction, and can I say this is in the downward direction? While returning back, can I say initial velocity is 0? And let's see with what velocity it hits the ground. Okay, then we will be using what? V is equals to u plus of at now. Or V is equals to, we don't know. U is what? 0 minus of gt. Minus of gt. Now object is going in which direction? Upward direction, downward direction? Downward direction. If object is going in the downward direction, obviously it comes with the negative side. Yes or no? Or can I also say that by removing the sign, t is equals to v upon g. If I consider the sign, then and then only time become positive, or time cannot be in negative. Yes or no? So can I say that time is also equal to v upon g? And the third thing what we need to discuss is, do u and v becomes equal or not? Okay. Now, what I am saying is, if this u is equals to u and if v is equals to what? We got v na with a negative sign. Yes or no? Let's see, is those are equal or not? V square minus u square is equals to 2as. So v square minus of u square is equals to, can I write 2g into 0? Can I? Yes. Because object is thrown from the ground, reached back to the ground. So can I say that v square is equals to u square? V square is equals to u square. Okay, now substitute the sign convention. In the upward direction, all are positive. In the downward direction, all are negative. So can I say that this u is positive and this v is negative? And cancelling this square and square, so u is equals to minus of v, or u is equals to the magnitude of v. I got my point? That means, can I say that if I am throwing the object at 100 meter per second, object will hit the ground by 100 meter per second. If the velocity after 1 second, is 90 meter per second, then while returning just above the ground is also 90 meter per second in this direction. This one is in this direction. Directions are opposite, but the magnitudes are equal. After 2 seconds, the velocity becomes 80 meter per second. Then in this downward direction, can I say that at this point, velocity is also 80 meter per second? Yes or no? So this tells you that with what velocity you are throwing the object, it will hit with the same velocity. If the velocity in the upward direction after 5 seconds, let's say 5 seconds. So without using any formula, if initial velocity, if I am saying that 100 meter per second, after 5 second velocity become 50 meter per second now. So from here to here it will take t is equals to 5 seconds. Yes or no? Okay, just before hitting the ground, before 5 seconds, can I say that the velocity will be same? Velocity will be same. Yes or no? So what are the equation we got? Time of flight t is equals to 2u upon g. This is the total time. Or time of ascent is equals to u upon g. Or time of descent is equals to v upon g. We already know that u is equals to v in terms of magnitude, or u is equals to minus v. Can I say that if both are equal, then if I add these two, then time of ascent, plus total time is equals to time of ascent plus of time of descent, that is t is equals to u upon g plus of u upon g, that is nothing but 2u upon g. Can I? Okay. Or can I also say that this is equals to, t is equals to 2v upon g. If you have the final velocity, you can calculate the time. If you have the initial velocity, you can calculate the time. But this velocity is just before hitting the ground. This initial velocity, when we thrown, what is the velocity? Yes or no? Okay. Explain yourself. Okay. The next thing is, write the next heading. H max. Okay. Object is thrown from here, reached here, velocity becomes 0. Wherever the velocity becomes 0, can I say this is your h max? Or yes or no? Initial velocity is u, g is acting in the downward direction. Okay, now, so v square minus of u square is equals to 2g, can I write h max? And g is negative. Can I? Final velocity is what? 0. So, minus and minus cancel. U square is equals to 2g h max, or h max is equals to u square upon 2g. U square upon 2g. Write all these formulas in one side. Time of flight is what? 2u upon g. Time of ascent, u upon g. Time of descent, u upon g. Are yes or no? And the last thing, u is nothing but minus of v, or u's magnitude is equals to v's magnitude. Okay, shall I now? No one will be helping your friends. Only the person will tell the answer to whom I ask. Okay, and u is equals to, let's take 100 meter per second. H max. Formula H max. H max is equals to 2u upon g. Are you sure about that? H max is nothing but u square upon 2g. Okay, second, time of flight. 2u upon g. Third, time of ascent, u upon g. Fourth, time of descent, u upon g. Okay, now it reached to h max. What is the velocity at h max? 0. Okay. Now, will it come back to the ground? Yes. Where is the g acting? When the object is going in the upward direction, g also acts in the upward direction, downward direction. Okay. G is also acting. G always acts in the downward direction. Now, questions are, first question, calculate h max. Second, distance after 12 seconds. Third is time of flight. Fourth question is velocity at t is equals to 5 seconds and 15 seconds. Then, okay, calculate these things. Okay, shall I? First answer, h max. What is our formula h max? U square upon 2g. So h max is equals to what? U is 100 into 100 upon 2 into 10. So h max is what? 500 meters. First answer is done. Second answer, distance traveled in the 12 seconds. Let me do this answer, and I am doing the answer from your books only. So S is equals to ut plus of half at square. How many of you use this formula? Yes, very good, very good. And can I say that S is equals to U is 100, time period is 12, minus of half into 10 into 12 into 12. Can I write like this? Okay, so once this is 5, S is equals to 1200 minus of how much is the answer? 12 into 12 into 5, 720. Okay, so S is equals to final answer 480 meter. Is this answer correct? Why? Answer is wrong, beta. The question is asked to calculate distance traveled after 12 seconds. Okay, why it is wrong I will tell you. For displacement the answer is correct. Turning point, same logic. Velocity is getting 0. Okay, now let's find first time of flight. So to calculate time of flight, what is our formula? Time of flight is equals to 2u upon g na, and 2 into 100 upon 10, that is nothing but 20 seconds. That means time of ascent is half of that. So time of ascent is how much? 10 seconds. That means can I say that body reached to the H max and in 10 seconds. So body reached to H max, and that is how much H max we got? 500 meter in time period of 10 seconds. Okay. After 10 seconds, at t is equals to 10 seconds, velocity becomes what? 0. If velocity becomes 0, obviously object will be returning back. If object is returning back, then distance and displacement both will be different. Very good. Okay, what you have got the answer is from here to here 480 na. That answer is correct. For displacement, answer is correct. But for the distance from here to here, that is 500. And from here to here 480. That means from here to here is how much? 20. So what is the distance traveled answer should be? Distance travel answer should be 500 plus of 20, and that is nothing but 520 meters. Are yes or no? Okay, anything else left out? Answer number 4. So answer number 4, what is the velocity at t is equals to 5 seconds and t is equals to 15 seconds? How to find that? So let us calculate that. So v is equals to u plus of at. V we don't know. We don't know. And we are calculating that. So u, initial velocity is how much? 100. Minus of 10 into t. And t is given na, after how many seconds? 5 seconds. So v is equals to, can I say that 50 meter per second. So what is the velocity after 5 seconds? 50. Okay, now. So consider from here to here, time period it took 5 seconds. Now I will tell you without doing any calculation how to get the answer. What is the initial velocity? 100. And what is the acceleration due to gravity? 10. In which direction? Downward direction. Acceleration decreases the velocity or increasing the velocity when the object is going upward? Decreasing the velocity. After 1 second, 90. After 2 seconds, 80. After 3 seconds, 70. After 4 seconds, how much? 60. After 5 seconds, 50. Similarly, if you calculate decreasing by 10 meter per second velocity at the height h max, it will decrease the velocity to 0 after 10 seconds only. Are yes or no? Okay. Similarly, I already told you that if you calculate the velocity at this point, same will be the velocity when the object is returning. At this point, if I am saying the velocity is 50 meter per second, while returning also the velocity at this point should be 50 only. Let us calculate that also and see. Now, from the h max returning back, initial velocity becomes 0. Yes or no? So v is equals to u plus of at, and initial velocity is 0. So v is equals to minus of g into, while returning back, what is the time period? 5 seconds. So v is equals to minus of 50 meter per second. Initially during the discussion, I told you that the velocity at this point should be going in the upward direction and the velocity at the same point should be coming in the downward direction. Both will be equal in magnitude but opposite in the direction. Ardhamainda? Okay, write down everything.